This video will show you how to explore data from the lapdMouse project using the lapdMouse browser extension for 3D Slicer, a multi-platform, free, and open-source visualization tool for medical imaging. This video will show you how to explore the data with 3D Slicer. If you're not familiar with the lapdMouse project, please visit our website at lapdmouse.iibi.uiowa.edu. There you can find a table summarizing the number of datasets available by strain, gender, and particle size. The web download page lists individual datasets with their strain, weight, particle dose information, segmentation summary data, and links to the data repository. You should also visit the data representations page. The left-hand side shows the different file types we provide and their naming conventions. The main panel has example visualizations for the files provided. If you haven't installed the lapdMouse browser extension for 3D Slicer yet, you can download it from Slicer's Extension Manager. Once the extension is installed, you can access it from Slicer's Modules selector. Go down the list to lapdMouse and click on lapdMouse DB Browser. This opens the lapdMouse Data Archive browser window. On the left-hand side, you will see all the available datasets. If you click on one, the right pane shows all the available files in the lapdMouse archive. Every dataset has an info link that will open a browser window with detailed information specific to that dataset. Once you found a dataset you're interested in, you can load a set of commonly used files by clicking Load Standard File Selection in Slicer. This will download the files to the local computer if they haven't been downloaded yet, and load them in Slicer. Some of the files are very large and loading might take a while. Be aware that some files can be 20 gigabytes or larger and may not load at all on your computer. You can close the browser window once all the data have been loaded. After loading the standard file selection in Slicer, you will see the aerosol deposition image volume as red in the 2D slices. Low bar boundaries are marked by the thick colored lines. The airways are shown with the thin yellow lines. Using the slice sliders, you can move through the image volume. The tooltip indicates the directions you are moving. You can zoom into a structure using Control, click, and drag down. And you can pan through the image using Shift, click, and drag. Clicking on the box left of the slice slider always recenters and scales the dataset back to fit the whole data. We can lock the 2D windows together by clicking the pin in the top left corner of any of the views, then clicking the link button. Now we can switch to the tissue fluorescence by choosing the appropriate volume from the volume pop-up. This pop-up also allows you to change the visualization of the lobe's label map from outline to filled, or to hide the label map completely by clicking on the eye. Now let's look at the airway wall deposition mesh in the 3D view at the top right. You can center the 3D view by clicking the box icon at the top of the 3D pane. If you want to hide the pink box, rest your mouse over their pin, click the eye icon, and deselect the 3D cube. Now we can zoom in by right-clicking or control-clicking and dragging down. Now that we're zoomed in, we can appreciate the local aerosol deposition, where red indicates areas of high aerosol deposition and yellow are the areas of low to no deposition. Sometimes it is important to navigate to the same 3D location in the 2D slices. We can use crosshairs to see the slice intersections. Select the crosshair icon in the menu bar and enable Slice Intersections. Now we can move the mouse cursor over one of the image slices while holding down the Shift key, and the other 2D views of the dataset will automatically be linked to the same 3D location. I'll show you just a couple jumps through the data. You can do a similar navigation technique on the 3D mesh. You can rotate the tree to whatever point you want and click Shift and watch the 2D slices jump to that location. This works whether we want to find a large bifurcation or a small airway. lapdMouse browser loads volumetric images, label maps, and models with some default visualization parameters, which you might want to change to better explore certain aspects of the data. For example, you can go to the Volumes module, where you can adjust the visualization parameters of the images and label maps. I'm going to zoom in on a small airway by using a shift click and drag to pan, a right click and drag down to zoom, and center them up with a quick pan. Notice that pressing the Shift key moves all 2D slices to the same location. Back in the Volume module, double-check the active volume. In the Display section, you can change the color lookup table for the active volume. Here I'm changing it from green to red and back again. Below the lookup table is a checkbox that lets you turn off the interpolation and reveal the raw pixel values rather than the smooth version. In the axial slice, you can see just how pixelated the airways look now. The Display section also has a slider that can be used to adjust the window and level settings to better highlight the structures you are interested in. Dragging the slider itself will change the level, dragging the handles will change the window. To adjust visualization parameters of a mesh, you need to go to the Models module. We will select the airway wall deposition model. Now we'll scroll to the bottom of the module to find the Scalar section. Here we can adjust the color lookup table for the mesh, and the displayed scalar value range if we wish to change that. Scrolling back to the top of the module, Slicer shows all loaded models. Clicking the eye icon on the left of the airway wall deposition hides this mesh so that we can see the airway outlets model that was loaded by lapdMouse browser. Zooming in, you can see the colored patches representing the outlets. The 3D display section of the module allows you to switch the model's representation from surface to surface with edges to get an idea of the mesh's complexity. If you want to enhance the appearance of the mesh in the 2D views, go to the Slice Display section. I am increasing the line width to make the mesh intersections more visible in the 2D slices. You can turn off the intersections completely with the visible checkbox. Now let's go back to the lapdMouse database browser module and open its modal window via the Show Browser button. Previously, we used the Load Standard File Selection and Slicer button to load a few of the commonly used files from the lapdMouse archive, but there are many more files that might be of interest to you and can be visualized with 3D Slicer. To help you select files you're interested in, visit our website, lapdmouse.iibi.edu. airway.uiowa.edu by clicking on the link on the top of the module and navigating to our data representation page. There you can get an overview of the available data files. We would like to point out two more data files, airwaytree.meta and near-acinine-deposition.csv. Visualization of these file formats is not natively supported by 3D Slicer, but lapdMouse browser creates mesh models to visualize them. Select both files by using the Command or Alt key and then clicking Load Selected Files in Slicer. After loading is complete, close the lapdMouse browser window and go back to the Models module where we can see the additional models. If we hide the near-acinine deposition and airway outlets models, we can see the structural representation of the airway tree. The main branches for each lung lobe are labeled and are shown in different colors. Now let's turn the visualization of the near-acinine deposition model back on. The deposition measurements for each near-acinar region are visualized as spheres with their color representing the average deposition in this region. Rotating the dataset, one can see two areas that are more bluish, while the majority are more green. Blue indicates areas of relatively high aerosol deposition. For further information about the lapdMouse project and the available data, please visit our website, lapdmouse.iibi.uiowa.edu. For further information on using 3D Slicer, visit slicer.org.